Program you're about to listen to is English Podcast 360 Degrees, 10-minute English.
The Earth is home to an astounding variety of trees with approximately 1 billion trees spanning over 60,000 species. These remarkable organisms are found on every continent except Antarctica. Despite their seeming vulnerability to environmental changes, they can't exactly pack up and move when conditions become unfavorable. Trees have demonstrated incredible resilience. They've been around for nearly 400 million years, surviving multiple extinction events. Their ability to break down rocks, create soil, and convert carbon dioxide into oxygen has made our planet habitable for us humans. While we may appreciate trees for their beauty and utility, understanding them has always been challenging. Unlike animals, trees are immobile and lack nervous systems, blood, or lymph. They only need sunlight and water to produce their own food. Some trees can live for thousands of years, like the ancient bristlecone pines, which are over 5,000 years old. In a forest, trees often appear as solitary individuals competing for sunlight. But there's more to their story. Beneath the forest floor, beyond what our eyes can see, lies a vast network of communication, a secret language of trees. This network allows trees to share resources, send warnings, and pass down information through generations. Scientists have discovered that trees behave as if they're part of a single organism, thanks to this intricate web of connections. One of the most intriguing discoveries is the role of fungi in this network. Mycorrhizal fungi form symbiotic relationships with tree roots, creating a vast underground web that connects different trees. This network enables trees to exchange nutrients and information, essentially allowing them to talk to each other. Trees can warn their neighbors about pests and diseases, share resources like water and nutrients, and even support the growth of young seedlings. Mutualism, a type of symbiosis where both parties benefit, is a fundamental aspect of many organisms' biology. Think of the clownfish and anemone, or bees and flowers. But one of the most significant and widespread mutualistic relationships is between soil fungi and land plants. In the late 19th century, a German botanist named Albert Bernhard Frank proposed that plant roots and fungi work together. Initially met with skepticism, his ideas were later proven true. Today we know that mycorrhizal associations are present in nearly all ecosystems, from deserts to tropical forests. About 90% of terrestrial plants form relationships with these fungi, creating an extensive underground network. Mycorrhizae, the fungi in these relationships, grow in association with plant roots, forming structures that allow them to interact and share resources. There are two main types: arbuscular mycorrhiza, which penetrate root cells, and ectomycorrhizal fungi, which form a sheath around roots. Both types provide water and nutrients to their plant hosts in exchange for sugars produced through photosynthesis. As we unravel the intricate web of connections beneath our forests, we begin to understand the profound intelligence and resilience of trees. These silent guardians of our planet communicate, share resources, and support each other in ways that challenge our understanding of nature. By embracing this knowledge, we open the door to new possibilities for conservation and sustainability. Our forests are not just collections of individual trees, but vibrant communities that thrive through cooperation and mutual support. In protecting these ancient networks, we safeguard not only the trees themselves, but the delicate balance of life on Earth. As we continue to learn from the secret language of trees, we take vital steps towards a future where humans and nature coexist harmoniously.
Wow, what a fascinating topic today, Emma. Absolutely, Rayan. Just think about how mature trees use their roots to gather water and nutrients, not just for themselves, but also share with younger trees through mycorrhizal networks. It's like a community effort for survival, especially during tough times.
Trees really are more social than we ever imagined. And did you hear about the mother trees? Those old giants are pivotal. They connect and support the forest ecosystem by sharing resources with seedlings. Losing them due to logging could seriously harm the entire forest.
Right. It changes how we should think about forest management. Instead of chopping down those big trees, we should preserve them to maintain the ecosystem's balance.
Plus, this insight can revolutionize reforestation efforts. Planting diverse species and ensuring healthy mycorrhizal fungi can lead to robust, resilient forests right from the start.
Absolutely. And these healthy, connected forests are crucial in the fight against climate change. They're better at storing carbon and coping with extreme weather.
Promoting these natural networks in agriculture is also a win-win. It can reduce our reliance on chemical fertilizers, which is great for the environment.
In the end, understanding the hidden connections in nature teaches us that cooperation and mutual support are essential for survival.
Exactly. Now, before we wrap up today's episode, let's dive into the vocabulary section. We have some important terms related to trees and ecosystems that our listeners should know.
Program you're about to listen to is English Podcast 360 Degrees, 10-minute English.
To enrich our understanding, let's take a moment to dive into some key vocabulary terms related to our topic. These words will help us grasp the incredible relationships between trees and fungi in a forest ecosystem. Mycorrhizae, a symbiotic relationship between fungi and plant roots that allows them to exchange nutrients and support each other's growth. Example: mycorrhizae help tree roots absorb more water and nutrients from the soil. Mycelium, the network of fungal threads or hyphae that spread throughout the soil, connecting different plants and trees. Example: the mycelium forms a network that links trees together underground. Mutualism, a type of symbiotic relationship where both parties benefit from the interaction. Example: trees and fungi have a mutualistic relationship because they share resources and help each other grow. Wood wide web, a term used to describe the complex, interconnected web of roots and mycelium that links trees and plants in a forest. Example: through the wood wide web, trees can send signals to warn each other about pests. Arbuscular mycorrhiza, a type of mycorrhiza that penetrates root cells, forming intricate structures to facilitate nutrient exchange. Example: arbuscular mycorrhizae help plants get more phosphorus from the soil. Mother tree, a large old tree that plays a crucial role in the forest by supporting younger trees. Example: mother trees send nutrients through their roots to help smaller trees grow and stay healthy.
All right, folks. Now that we've explored a treasure trove of fascinating words and concepts, let's move on to our final segment. I've got some intriguing questions lined up that will delve even deeper into the secret life of trees. Let's get into it. Question 1. How do trees communicate with each other? Question 2. What is the role of mycorrhizal fungi in tree communication and support? Question 3. What is a mother tree and why is it important in a forest ecosystem? We've covered some incredible ground today. For those eager to dive even deeper, don't forget to download the PDF, which includes the transcript and vocabulary of this episode. It's packed with all the details we've discussed and more.
And as always, if you enjoyed today's episode, make sure to subscribe to our podcast. We have plenty more fascinating topics lined up that you won't want to miss. Thanks for tuning in, and we'll see you next time.